Welcome back to the deep dive. Today we're embarking on a journey into, well, the very heart of flight, something absolutely critical if you're fascinated by how these incredible machines work.
Absolutely. How they move through the air.
Especially if you're, like many listening, maybe gearing up for those demanding ATPL theory exams. Well, this deep dive is going to be, let's say, your secret weapon.
Mm-hmm.
We're not just scratching the surface, we're plunging into the intricate art of aircraft flight controls and the delicate balance of trimming.
Yeah, get ready to unlock some, really fundamental secrets of flight dynamics. Stuff that's directly from the source material you need to master.
That's exactly our mission. We're going to systematically dissect this complex, yet, I think, elegantly logical world of aircraft flight controls and trimming.
Our goal is really to extract the most vital nuggets of knowledge from the provided aircraft flight controls and trimming excerpts. We want to translate what can feel like incredibly dense theory
It often does.
into clear, memorable insights. Insights that will not only arm you with the answers for your exams, and believe me, it absolutely will, but maybe more importantly, build a really rock-solid, foundational understanding of how an aircraft truly responds to every single pilot input.
Right.
So we'll be focusing on answering specific questions, things like fundamental definitions, the clever control mechanisms designers use, the crucial balancing acts involved, the nuances of trimming, and their critical practical implications.
This isn't just about memorization, then.
Not at all. It's about making you not just informed, but really well-informed about those invisible forces at play every second a plane is in the air.
Okay, let's unpack this and maybe start with the very architecture of flight. How these magnificent machines actually achieve controlled movement through three-dimensional space.
That's good.
At its core, every aircraft control system has one fundamental purpose: letting the pilot precisely maneuver and, crucially, trim the aircraft in flight.
Right. Maneuver and trim, both vital.
And these movements, as we know, happen around three primary axes. They all pass through the aircraft's center of gravity, or CG, and control is typically achieved via, well, what we call flap-type control surfaces.
Like little panels?
Exactly. Think of them as small, movable panels on the wings or tail, strategically positioned for maximum leverage. That means they have the longest possible moment arm about the aircraft's CG.
It's like pushing a door, right? You push near the handle, not the hinge.
Perfect analogy. It's all about getting the most effect, the maximum turning force or moment around those specific axes.
That's a great way to put it. It really is about generating that powerful turning force, a moment, around those specific axes. So let's clarify those crucial definitions, because these are really the ABCs of flight.
Good idea. Foundational stuff.
When we talk about pitch angle, we're talking about rotation around the lateral axis. Imagine a line running side to side, wingtip to wingtip, like a giant skewer through the aircraft.
Okay.
That's how you pitch the nose up or down, controlling climb or descent.
Got it.
Then there's roll angle. That's rotation around the longitudinal axis, that invisible line stretching straight from the nose to the tail.
Like rolling the aircraft side to side. Banking.
Exactly. Banking left or right for a turn. And finally, yaw angle. Rotation around the normal axis, that's the vertical line, straight up and down through the fuselage, perpendicular to the other two.
So the nose moves left or right, kind of like shaking your head no.
Pretty much.
Yeah.
It's technically defined as the angle between the aircraft's longitudinal axis and the relative airflow. So yawing is a rotation around, that would be the normal axis. You need to know that one.
Okay, normal axis for yaw. Got it. So each of these axes has its dedicated primary control surface, right? Designed specifically to make that rotation happen.
Precisely.
For control and yaw, our directional control around that normal axis, we use the rudder. You see it on the vertical tail fin swinging left or right.
Steers the nose.
Yep. Making those small adjustments to fly straight or coordinating a turn, that's the rudder. Then we have the elevator for control in pitch. That gives us longitudinal control around the lateral axis.
So pitch means longitudinal control, and the surface is the...
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.